So I heard you like pandas. Well, everybody love pandas, right? And so do we. Data scientists and analysts, enthusiasts, we love pandas because if you are getting started with Python, pandas is something which is going to be with you forever. And hello everyone and welcome back to my channel. Today's topic is going to be on pandas and it's one of the most important libraries when it comes to data science and analytics. So let's get started. I already have one video related to pandas 1 year back probably, but this is having new content. This will basically cover a lot more about pandas, and if you are a beginner in this field, this video is definitely going to help you out. So let's get started. Now, in the previous video, I talked about numpy, which is a numerical Python. We already saw that numpy is quite faster as compared to the traditional programming. Today's topic is more about pandas. Let's start. What exactly is pandas and what are the various methods present inside pandas? Before getting started, guys, just a small disclaimer. If you think this 15 minutes video is going to be more than enough, well, it will cover most of your questions. It will cover most of your methods present inside pandas, but honestly speaking, pandas, numpy, matplotlib, these are like ocean. Every day is a new learning for you. So this is going to definitely be a kickstarter for you, but as time goes on, you have to practice and more practice, and that's where you can become a pro in pandas and in different libraries as well. So let's get started. Before getting into the the importing part and the methods, the most important thing is installing pandas. If you're using Anaconda, probably you will definitely be having pandas already pre-installed. But in worst case, while importing pandas, if you are getting an error, which is a very rare scenario, in that case you have to do pip install pandas. So I have already imported pandas as PD. We already know as PD means I'm providing an alias for this one, as np basically means my alias for numpy, and here I'm reading a file which is called as churnmodeling.csv. Okay, and if you are reading an Excel file, you can read using read underscore Excel. If you are using a text file, read underscore text. So something like that, right? So once you have done the reading, then it is done by pd.read underscore csv, and you pass your file name. If your file name is present in the same location as your Python file, you don't have to specifically give the location. In case it's another location, you have to give the full location like this. Okay, something like this. So let me run this. Before running it, we have to run the import methods as well. And then I run the read CSV and it is done. I just opened the file, so my kernel is very much fresh and active, so that's the reason it is taking a little bit of time. Now once you have done reading the data frame, your next task is to see your data frame. Now data frame is very similar to what a table is all about. In Excel files, you see a different number of columns, you see different number of rows, right? Data frame is just the pandas version of tables. So you can read any type of tabular data when it comes to data frames. In case you are using an Excel file, in Excel files, we do have multiple sheets, right? So while reading the Excel file, you have to also mention sheet name is equals to this. Okay, so DF is basically giving me the entire picture about the data frame: row number, customer ID, surname, credit score, geography, gender, age, tenure, balance, all the features. It shows me 10,000 rows and 14 columns. So the very first thing what we do after this is we do dot head. Dot head function or dot head method basically shows you the head of the data frame. For example, if you want the top 10 records or top 5 records, so in that case, you can simply pass head of 10. It gives you an output of 10 records. If you want 5 records, you can pass 5. Or else, if you don't pass anything, then also 5 is the default values. Similarly, we also have tail for the last few records. df.tail is basically giving me the tail records, the tailed records. Okay, the last 5 records of the data frame. Now, Pandas functions and methods are going to be super easy and super simple to learn because it's very user friendly. Suppose you want the entire information about the data frame, you have info. You want the statistical information, you want to have a description of the statistical information, what is the mean, median, and blah blah blah, we have describe method. You want to see what are the data types present, whether it is an integer, float, string, object, d types. So very simple to learn, and of course in just one class it will be very difficult for you to understand. Practice, practice, and practice. Okay, so dot info is giving me an idea about the data frame. It's giving me information that this is a data frame. It has this much of records. These are the columns. These are the non-null activities, non-null columns, and these are the data types. In case some of your columns has some non-null values, then probably you can do some null values imputation, which again requires a little bit of statistics. So we will not be covering that in today's class. Today's class is basically on pandas, entirely on pandas, only pandas, just pandas. Okay. And then dot describe is basically describes the statistical information of the numerical columns. Let's say your data frame has 20 columns. Out of 20, 5 are categorical. That means gender, location, something like that. And rest 15 are your numerical columns. So describe method only takes the numerical columns and gives you the results. You can see results are in form of 25 percentile, 50 percentile, maximum, what is the max, what is the mean, what is the count, what is the standard deviation, and all these things. Some statistical information. If you want to see the total number of columns, the name of the columns, of course, you will be getting it by dot head. But sometimes when you have too much of columns, then you see some dot 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 here. Like there will be some columns and then some dot dot dot, and there will be some columns. That means the entire picture is not shown. So in that case, you can just print df.columns, which will give you the list of all the columns. Then comes your transpose method. Sometimes we need to convert rows to columns and columns to rows. In that case, dot t is the method to use. Transpose. Earlier we had 10,000 records and 14 columns. Now we have just the opposite. We have 14 rows and 10,000 columns. Okay. Our very next method is going to be sorting. So many times while doing some data analysis on Excel or any of the tools, we basically sort, right? Sorting based on A to Z or based on numbers, right? So sort underscore values will give you the sorted output. If you want to store this into a new data frame, you can simply call new df equals to df.sort values age, and your new df will have all the sorted values. Okay, like sorted based on age. I'm just deleting it. So we are not concerned about creating a new data frame. So sort values will basically sort you everything. The community of pandas, not the pandas community, the community of Python is so great. Even if you don't remember all these things, if you just simply Google, let's say I just forgot what is sort underscore values. Like to sort a column, we have to use sort values. I just forgot. So sort pandas column in data frame. If you just search it, you will get it on the very first page, sort underscore values. That's how good the community and there are a lot of resources where you can get your things done. You don't have to memorize all these things, and nobody in an interview asks you, can you write down what is the method for sorting a data frame based on this column? No, nobody asks that. Okay, so sort underscore values gives you an output, sorted output based on your age. And then I just want to print balance. So this is how you can print, or else you can also print using df.balance. df data frame dot column name. But dot column name will not work in case your column name is having some spaces. For example, your column name is input balance. So in this case, you can do like this, but you cannot do like this. Okay, this is the drawback. So in that case, you can just do df of the column name and you get the output. Now our next step is Let's say I want to derive some columns based on my previous columns. For example, I have balance. I want to add $1,000 to each and every employee and create a new balance column. So in that case, adding $1,000 is not a big deal. We just have to do column plus 1,000 because this is a simple arithmetic operation. And then you assign this to a new column. You can see I'm assigning this to, sorry, a new column, which is DF of new balance. Now, how this works is if you already have a column name called as new balance, then the values will be updated. If you don't have a column based on this name, a new column will be created. That's how data frames work. If I run this, this is how my new data frame looks like. I have a new column, which is new balance. Let's say I want to have a hard coded column. Let's say I want to hard code a column to have values like good day, good day, good day. So simply df random column equals to good day. And if I do this, this is how it looks like. Very simple to do. Our next steps is to access the rows of a data frame. Now, people who already are looking at this video, I assume that you have little bit of knowledge on Python as well. Before this, we already know that this is how we used to access a string object. Like let's say I have string. So how to access the first element? str of 0. How to access the first two elements? str of 0 to 2. Exactly same fashion we have to do for data frames as well. So 0:2, that means I will get the first two records. 10:12, that means I will get the 10th record and the 11th record. The last number is not inclusive. That's basics. It's the same thing in string, same thing in list as well. Okay. And then moving on to the next one, which is your conditional operators. Okay. Conditional operators. I will just do some changes on the go. Conditional statements. That means where clauses. In SQL, we have where clause, right? Let's say, can you find me the total number of records where the age is greater than 50? That means select star from table name where age greater than 50. That's in SQL. So in data frames, how it works is this way. So if I just print this, that means data frame of what? Age greater than 50. If I run this, I'm getting the result like this. All the ages which is more than 50 are being printed out. Let's say I want to store that in a new data frame called as new df. I store this and then I print what is the length of this data frame. Length of this, you can see 1261. What is the length of the original data frame? 10,000, which means 1261 candidates are having age more than 50. As simple as that, right? No rocket science in this. Now, if I just show the head of this, this is how the head looks like. Age 58, 51, 61, blah, blah, blah. Similar fashion, I'm just creating a same data frame, which whatever I have already taught. Moving on to the next one, which is null values. How to treat null values. So fill NA and drop NA. Okay. So of course, how to treat null values is again a very vast topic. There are many statistical approaches or time series forecasting approaches to fill a null value, but as I told that we need statistics for that. Today's topic is going to be entirely on the basics of Python, basics of Pandas, right? So Pandas data frame provides a method called as fill NA. That means any null values, any NA values, fill it with 10 or fill it with 20 or fill it with the mean value. Okay, so how to find the mean value of age? Age df.age.mean will give me the mean value, right? In case you want to pass this, it works, no problem in that. Okay, that means you are filling all the records by the mean values. In case you want to do a hard coded value like 25, works, not an issue. And then if you print head, so next topic is going to be on removal of columns, column removal or dropping. Okay, so there are two methods for dropping columns. There could be more. I'm not pretty sure about that, but the major methods are pop and drop. That's it. So that means if you are trying to drop row number, then you can simply call df.pop row number. If I do this, my new DF doesn't have the row number. You can see no row number is there. Similarly, you can also use drop. Okay, drop of row number. And then if I do head, row number is gone. Boom. And then moving on to the next one, to apply some operations, some numpy operations on any column. So let's say we have balance, and here we are applying np dot square root. That means I'm applying the square root of this one. Okay. And if you want to apply and then store the values in another column, simply assign this a column. Sq of this is equals to this. This is exactly the same thing which I have done in the next step, which is here. So here I'm creating a new column, which is balance dot apply np dot square root. And then comes dropping all the null values in each column using drop na. So these are some naive techniques, some idiotic approaches, but sometimes it helps you, right? But of course, statistics is very much required because we have to analyze and then only we can drop all these things. So just understand the different methods and how and when to use. Probably you can check out my other videos related to exploratory data analysis and all those things. Statistics videos are coming soon, guys, just for your information. Probably next 2 weeks, the entire statistics playlist will be there on my channel. Okay. And the next step is going to be concatenation and merging. What is concatenation? Same things. String 1 equals to hello, string 2 equals to world, and how to concat string 1 plus string 2. What is this? Hello world. That's string concatenation, right? Just appending one on top of another. Similarly, if I have two data frames like this, A, B, C, D, I'm concatenating it. Here are the results. The DF1 looks like this, DF2 looks like this, and the result looks like this. 8 records. Okay. Then comes your merging, which is one of the important topics because this requires a knowledge on SQL as well, little bit of knowledge, because we must have studied about inner join, outer join, left join, right? So what are different types of join in SQL? You can see this image, very simple image. So you can see two circles. The common elements are basically your inner join. What does that mean? That means if I have a table 1 and if I have table 2 and I have the employee IDs like 1, 2, 3, I have employee IDs 1, 5, 6. So the inner join will be just 1. The outer join will be 1, 2, 3, 5, 6, right? Something like that. The left join will be 1, 2, 3, right? Something like this. So if I just do this, and then I'm doing an outer join, this is how my merge DF looks like. You can see the common column is C, A, B, C, D, and E, F, C, G. So common column is C. That means I'm merging data frame 1, data frame 2 on C. How? Outer. That means I'm doing an outer join. So all these elements will be present. C0, C1, C2, C3, C6, C7. So there will be 6 records. You can see C0, C1, C2, C3, C6, C7. And if I do inner join, there will be 2 records, which is C0 and C3, which are the common elements. If I run this, you can see only C0 and C3. Okay, this is how it works. And then our next topic will be LOC versus ILOC, one of the most complex things. And then we will wind up the basics of Pandas. So LOC versus ILOC, the major difference between these two methods are LOC gets rows or columns within particular labels. ILOC gets rows or columns at integer locations. What does this mean? I hope everybody knows about index values, right? If you create some data frames, you create something, indexes are also created automatically. In SQL as well, people who have SQL knowledge, they will be able to understand the meaning of indexing, right? So for example, I'm creating a series. I will not define the indexes. So how many elements do we have? A, B, C, D, E, F. If I run this, this is how my series looks like. The left part is my index. My right part is my values. Okay. So if I'm providing an index like this, that means I want A to be assigned on 49th index, B to be assigned on 48, and so on. So S of LOC of 0 will be the 0th index element, which is D. But ILOC of 0 will be the location. The first location is 49th location. That means the output will be A. So you can see S of LOC of 0, the value at index level 0. What is this? This is D. S dot ILOC of 0 is A because this is the first location. LOC is by indexes, ILOC is by locations. That's the only difference. Okay. But when you are accessing multiple elements, like you are accessing your data frames, like hello world, you want the first two letters 0:2, right? The end one is not inclusive. So in LOC, the end number is inclusive. In ILOC, the end number is not inclusive. That means S.LOC 0 to 1, that means 0 and 1. That means D and E. ILOC of 0 to 1, that will be only 49, which is A. ILOC of 0:2 will be A and B. Now, what if I sort the series based on the indexes? Or else if I just don't have indexes? In that case, my ILOC and ILOC will be same, right? Yes, it will be same. Let's see. What if you sort the series? Let's say I have sorted it. This is how my series looks like. So here, LOC of 0, who is at 0th index? D. ILOC of 0, who is at 0th location? D. So LOC of 0 will be D. ILOC of 0 will also be D. Okay. Now, LOC of 0:1, which will be D and D because inclusive of both the elements, right? And ILOC of 0 to 1 will be just one element. So this is just a small meme that, so I heard you like pandas. Well, everybody loves pandas, right? And so do we. Data scientists and analysts, enthusiasts, we love pandas because if you are getting started with Python, pandas is something which is going to be with you forever and one of the most important libraries. So that's it from my side. Of course, this is not an end-to-end pandas thing, but definitely this will cover most of the things. Okay. And again, it's a recurring process. It's a practice. Practice is required. So I hope you all the best. Practice, practice, and practice. Keep practicing, and that's where you will learn and become a professional in Python. That's it from my side. Next class will be on matplotlib and Seaborn. That's it. And we have many more interesting topics as well. Of course, you can see I have recently changed my house. So a lot of vlogs will be coming as well. So stay tuned. Bye bye. Thank you. Please like, share, and subscribe the channel. And in case you haven't, press the bell icon to get notified on the channel so that you get all the notifications on your mobile. So that's it from my side, guys. Thank you and have a good day. Bye.